Hello, 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 hello! And now we are doing 7.1, number 2. Now, in 7.1, number 2, you're in your car, driving as fast as you can. And then up ahead of you is a loop-de-loop. Woo! Now, in order to do a loop-de-loop, you have to go pretty fast to get the centripetal force needed to stay in the loop. Because if you're up at the top of the loop in your car, and it's not equal to gravity, it kind of looks like a fish, doesn't it? If your centripetal force is less than gravity, well, gravity is going to take over and you're going to fall and die. So when you're going, your centripetal force, Fc, must be greater than or equal to 9.8 meters per second squared. Is that not right, Earthlings? Yes, it is. So we are trying to find centripetal acceleration that needs to be greater than 9.8. So at the, minor mistake, not Fc. Centripetal acceleration needs to be 9.8 or greater. Okay, so our formula for centripetal acceleration is this. AC, acceleration centripetal, is equal to your tangential velocity squared over the radius. We are trying to find, at your car's max speed, what is the biggest loop you could possibly do? What is the biggest loop that you could possibly do where your car could go fast enough to avoid falling? So, AC, we had said it has to be 9.8 or bigger. I'm just going to put down 9.8 is equal to, my car's max velocity is 42 squared over R. That's what we're trying to find. Now, let's get started with this. Now, I would like to rearrange it. So I would like to multiply both sides by R and then divide both sides by 9.8. And the R cancels the R, the 9.8 cancels the 9.8, and I end up with R is equal to 42 squared over 9.8. So, going through that, 42 squared, I did that in my calculator and came up with 1,764 over 9.8. That all equals R. And when I divide that, I get a radius of 180 meters, which is a good size radius. Because think about it, this loop is really big. Remember, the radius is only from the center to the outside. The loop itself would be a full 360 meters, which is a little more than 3.5 football fields in length. Now, could you really do this? No. And the big reason is, yeah, if you could keep your car going that speed, you'd be able to do it. But think about what's happening here. You're going max speed, you go up here, you're going to probably not maintain max speed. By the time you're at the top of the loop, you're going to probably be going a lot less than max speed, and you're going to fall. But let's just say you could keep that speed up. If you could keep that speed up, yes, you would be able to do a loop that big. But you can't. So, now, by the way, quick question. Let's think about this on your standpoint. What is your number going to be? Is it going to be bigger than mine or smaller than mine? Well, your car is probably not an economy electric car. So your speed is probably going to be a lot faster than mine. In fact, it's going to be faster squared. If your max speed is twice my speed, your loop will actually be 4 times as big. Again, if this could really be done, which it can't. So just be aware of the fact you may be getting a crazy huge number. If you could somehow keep that speed up for the whole loop, which you can't. But if you could, this is definitely what you would be getting. So there you go, 180 meters, and that's that.